Every developer dreams of building software that can actually grow and scale, right? Well, to do that, you can't just wing it. You need blueprints. And that's exactly what we're diving into today, the essential architectural blueprints for any Java developer. We're talking about design patterns. You know the feeling, right? You kick off a new project, and the code is just clean. It's beautiful. But then, as it gets bigger, feature after feature gets bolted on, and this chaos starts to creep in. That elegant code you were so proud of, it becomes a tangled, unmanageable mess. So what gives? Why does perfectly good code go bad? And the signs are always the same, aren't they? You start seeing the same logic copy-pasted all over the place. Different parts of your system get so tangled up, so tightly coupled, that changing one tiny thing over here breaks 5 other things over there. Writing tests becomes a total nightmare, and every single deployment feels fragile, like you're walking on eggshells. That is the chaos that stops the system from scaling. Okay, but it's not all doom and gloom. There is a way out of this mess. There's a set of proven, battle-tested solutions designed specifically to fight this kind of chaos and bring structure back to your code base. And these are your architectural blueprints. So, what exactly is a design pattern? Look, it's not some high-level abstract theory. It's a practical, reusable tool. Think of it like a template for solving a problem that other engineers have already faced and solved thousands of times before. Using them means you're building systems that are loosely coupled, easy to extend, and safe to refactor, right from the very start. All right, you ready? Let's start building out our toolkit. We're about to go on a rapid-fire tour of the 8 most essential design patterns that every developer absolutely needs to know. Think of this as your starter pack for writing much cleaner, much more scalable code. Okay, first up, the Singleton. The problem it solves is simple. You need exactly one instance of an object, and only one, period. This is perfect for stuff like a configuration manager, a logger, or a database connection pool. You only want one of those floating around, right? It saves memory and keeps your global state consistent. Now, a little pro tip here. Use this one with care. That global state can make unit testing a real pain, so it's a bit of a controversial pattern these days. Next on our list is the factory pattern. So imagine your code needs to create different kinds of objects, like a credit card payment or a PayPal payment. All that creation logic can get really messy really fast. The factory pattern is your cleanup crew. You just move all that complicated logic into a dedicated factory class. Now your code just says, "Hey factory, I need a payment object." And the factory figures out all the nitty-gritty details. Super clean. The builder pattern. This one is a total lifesaver when you're dealing with complex objects. You've seen those constructors with like 10 different parameters and half of them are null? It's just a mess. The builder pattern lets you construct that object step by step, setting only the properties you actually need. The end result? Your code is suddenly way more readable, and you can say goodbye to that horrible constructor explosion. Okay, what do you do when you have 2 components that just can't talk to each other because their interfaces don't match? This happens all the time when you're trying to integrate with a legacy system or some third-party library. Well, that's where the adapter pattern comes in. It's literally a bridge. It acts like a universal translator, converting one interface into another so they can work together seamlessly, all without having to change their original code. The Decorator pattern is all about flexibility. Instead of creating a ton of different subclasses just to add new features, you decorate an object by wrapping it with new functionality. For example, you could start with a basic notification object, then wrap it with an email decorator, and then wrap that with an SMS decorator. You can just keep layering on new behaviors at runtime. It's incredibly powerful. Now for a really potent one, the strategy pattern. This is your go-to for when you have multiple ways of doing the exact same thing, like different payment methods or sorting algorithms. Instead of a giant, ugly if-else block, you encapsulate each algorithm into its own strategy class. Then, your main code can just swap these strategies in and out whenever it needs to, even while the program is running. It's a game changer for clean, flexible code. The observer pattern is basically the engine behind modern, event-driven systems. Let's really get this one. Imagine you have an order service. When a new order is placed, the inventory service, the email service, and the analytics service all need to know about it. Instead of the order service being tightly coupled to all of them, they simply subscribe to it. It's like a newsletter. When something happens, the order service just notifies everyone automatically. This creates a beautifully decoupled system, which is absolutely critical for scalable microservices. And last on our tour, let's unpack the command pattern. This one is all about turning a request, an action, into a standalone object. Now, why on earth would you do that? Well, because once a request is an object, you can do all sorts of amazing things with it. You can queue it up for later, you can log it, and you can easily implement complex features like undo/redo functionality. You're not just calling a method anymore. You're creating a command object that you can pass around and execute whenever you want. So we've seen the individual tools. Now let's zoom out and see how they build something much, much bigger. How do these patterns actually help companies create systems that can handle a massive global scale? This is where it all clicks into place. You can draw a direct line from using a pattern to a real-world scalability win. Singleton, that gives you resource efficiency. Factory makes it super easy to add new features. Adapter isolates your system from external service failures. Strategy lets you change behavior on the fly without a redeploy. And as we saw, Observer and Command are the absolute bedrock of event-driven scaling and async processing. Each pattern provides a direct, tangible benefit. And hey, this isn't just theory. This is how the real world works. Look at who's using these patterns. Google uses strategy and factory to route their immense traffic. Amazon relies on the command pattern to manage its complex workflows. The Spring framework that so many of us use every single day is literally built on patterns like factory and Singleton. Heck, even the core Java SDK uses Builder with String Builder and Decorator with InStreamPut. This is how the pros build. Now, with all this power comes a bit of responsibility. It's absolutely crucial to understand that these patterns aren't a silver bullet for every problem you face. The final and maybe most important part of the blueprint is knowing when and when not to use them. Because let's be real, there's always a trade-off. What you gain in clean architecture and long-term flexibility, you often pay for with more classes and a little more complexity up front. Now, for a huge, complex system, that's a fantastic deal. But for a simple little script or a small app, it might just be over-engineering. The key is to apply a pattern when it's going to simplify your life in the long run, not just complicate it right now. And that brings us to the single most important takeaway from all of this. If you remember one thing, make it this. Design patterns are tools, not rules. They're powerful tools in your toolbox. You wouldn't use a sledgehammer to hang a picture frame, right? You pull out the right tool for the job, and you use these patterns when the problem in front of you truly demands the flexibility and scalability they provide. So, as you head back to your own code, I'll leave you with this question to think about. Look at the challenges you're facing right now, that messy code, those difficult changes. Now that you have these blueprints in your head, what problem will your next pattern solve?